Section 6.4 is the last section in Chapter 6, and it talks about proportional reasoning. Proportional reasoning is actually very powerful. In some ways, I think it's a lot better than the way that we often teach students how to compare things, because it gives a really nice structure on how to make comparisons, and that's very helpful when you're looking especially at application problems and you're like, I don't know where to start on this. There's structure that's built into proportions. So in order to talk about proportions, we have to first talk about ratio notation. So ratio notation is written as A to B, or A over B. We read it as A to B. There's two different kinds of ratios, truthfully. There is a part-to-whole ratio, and there's a part-to-part ratio. And the example here is to try and show you the difference between those two types of relationships. So let's consider having 15 students, and 7 of them make A's on the test. A part-to-whole ratio would say that 7 to 15 is the A's compared to the whole class. A part-to-part ratio is 7 compared to 8, the A's compared to the not A's. Okay, so you guys see ratios all the time, and you see them from both perspectives all the time too, but you have to be really careful, right? So when you compare 7 to 15, what are you comparing? What pieces are you comparing? If you're comparing 7 to 8, what pieces are you comparing? Because if you write down 7 to 15 and you say that's the number of A's, well, A's compared to what? A's compared to everybody, or A's compared to not A's, right? So those kinds of things. So we're going to do an example with some gender ratios. So ratio of boys to girls in a class is 2 to 3. What is the ratio of boys to all the students in the class? So I'm going to write it just as a fraction to see it this way. So this is 2 boys, and it's compared to every 3 girls. And the reality is we don't need to know how many boys actually exist or how many girls actually exist to make the problem work. The ratio is enough, all right? The ratio is enough. So for every 2 boys, there's 3 girls. So how many kids is this total when you consider the ratio comparison? It's 5. We're talking about a 5-kid grouping. So like if you were grouping these kids in groups in a classroom, right, and you put 2 boys and 3 girls in each group, and this group, and this group, and this group, and this group, well, every group has 5 kids, okay? So there's 5 kids here, which means that if you want then to look at what the comparison is of boys to everyone, or you could say boys compared to boys and girls, right? Either of those relationships existing, what would the ratio be? It'd be 2 to 5. So you can say 2 to 5, or you could write it as an in-between step if it helps you to see it. It's 2 to 3 plus 2, right? It's the same 3 girls and the original 2 boys. That's where the 5's coming from. So the ratio is 2 to 5, or you could write it as 2 to 5 like this. Either of those ways of writing it would be appropriate. And just like we can take the individual pieces and combine them into the whole, the number of pieces, right? This was a part-to-part to begin with, and we turned it into the part-to-whole recognition at the end. We can go the other way as well. So if we have 3/7 of the class are girls, what is the ratio of boys to girls? So what this is saying is that there are 3 girls for every 7 boys and girls. So in this comparison, how many of these children, as they're grouped this way, are boys? 4, exactly. So this is looking at it as though we have a 3 compared to 3. Hang on, did I write it boys? I wrote boys first. 4 plus 3. And this 4 is the boys, right? So as we're thinking about it in that direction, what would the ratio of boys to girls be? Yeah, make sure that you think of it in the way that they've described it, not girls to boys. They did boys to girls in the question, so it's 4-3. Or you can write it like that. I mean, and as you're doing problems like this, I don't need to see the work that I've just shown you on the screen. I just want to make sure that everybody's clear where those numbers are coming from, because I'm teaching it from the first time too. So if you're able to do that kind of comparison quickly in your head, that's great. Okay, so this is the idea of ratios. Ratios is a comparison of two items. Sometimes it's a part-to-whole comparison, sometimes it's a part-to-part comparison. A proportion is simply a statement that two ratios are equal. So here's an example of one is A over B equals C over D. And if this relationship is true, that is that A over B is equal to C over D, there's a lot of other relationships that are also equally true, and they can be used interchangeably. And that's what the three theorems following this all say. They say, hey, if there's a proportion like that, you know what else is true? And they do some different things. So here's one of them, Theorem 620. Theorem 620 we've already seen. It says you can cross multiply and the things are going to be equal. Well, of course you can. We've already done that, right? Yeah. So if we multiply across the diagonals, we have AD equals BC. 621 and 622, they both actually show other relationships in proportion form that are equal. So I'd like for you to kind of see what they're doing on the first ones compared to the second ones that I'm sort of circling in this purple. What have they done to the fractions, to the ratios? Yeah, they've done the inverse. They've flipped them over, right? They've done the inverse to both of them. And if you were to cross multiply, you'd still end up with the same AD equals BC that we did before, right? So it should be true anytime you have a proportion that if you flipped both of them upside down, you'd still have a proportion and it would all be good. Can you tell what's happening on the lower one? On 622. Just in terms of placements of the A's, B's, C's, and D's. What have they done? They switched to the B and the C. Yes, they did. So this C was here, and the B was here, and they just changed the locations. So they just switched the diagonal. Obviously, again, if you cross multiply along the diagonals, right? Yeah, it's AD equals BC, just like before. So it has to be true. I mean, it has to be a true statement if I can cross multiply and it's going to still work. The other thing that would actually be true is not only could I switch the diagonal C and B, obviously I could also switch the diagonal A and D, right? That's not any different. It's just switching which ones, which one I'm talking about, this diagonal opposed to this diagonal, right? Like, it doesn't make any difference. You're just switching the diagonal. So that would be another way of getting a sort of an additional proportion of equality. So you might kind of think, okay, well, but it looks a little like magic, right? I'm just moving these things around and they're all still the same, so what's the point? Well, the point is that when you're making comparisons in actual real-life examples, that's really more like what it is. The proportion that I set up and the proportion that Cassidy sets up, they may not look alike when we first put them on the paper. I'm making different comparisons than Cassidy's making, like at first glance. But if they're set up to still be in relationship the right way, that can be okay. So we can start from a different perspective on the problem and still end up with solving the problem correctly. And that's actually very liberating for students to have this idea that there's more than one way to do the problem and end up with the right answer. It's really good stuff. So we're going to do some examples of some proportional reasoning problems. And you can see what I mean as we're talking about setting these problems up. Jim found out that after working for 9 months, he had 6 days of vacation time. If he accrues vacation time at the same rate, how many days would he earn in 2 years? So let me say this one time. I'll probably say it again. Let's just be honest. Everything that we do in this section has other ways to be solved besides proportions, and I understand that. But what we're trying to do in this section of material is practice solving them with proportions. Okay, so resist the urge to do anything different that looks like anything else you've done. We are working with proportions. That's our goal. Okay? You guys can do it. I know you can. You can resist that urge. So, what is being compared here? Somebody tell me. I'm just going to write a little bit, actually. What is being compared? Okay, months of what? Months of work. Whoops. To what? Days of vacation. On this one, we have to be a little bit careful to clarify the months and days because obviously 30 days in a month and we could get things mixed up a little bit. And all of a sudden there's a number of years here, so we have to be careful when we're writing the problem as well eventually that we recognize that that's a different unit of time as well. What else is being compared? There's always 2 things being compared. I'm sorry. What's that? No, but that's a good guess. We're going to have to make up for the fact that it says years in a minute, but there's something else. Kind of, yeah, along those ideas. So the other thing that's being compared here is now to later. You guys with me? What does he have right now, and what will he have later? So every time we do a proportion problem, there's always 2 comparisons being made. Now, this isn't the only way to do this comparison. You could say that we're going to compare the months of work now compared to his months of work later, and his days of vacation now compared to his days of vacation later. So you're comparing months to months and days to days. That's another way to do this comparison. Okay, so there's more than one way to even sort of state the comparisons that are being made. When we're looking at these comparisons, we're setting them up in a proportion form like so. And you have to decide how to set up your proportion. And again, you get to make the choice because there's more than one way. Are you wanting to compare the days of vacation, or like now on the left and later on the right? Are you wanting to compare days on the left and, months on the right? How do you want to make your comparison? So somebody's going to tell me what we're going to do, and we're going to go with it. So if you don't talk, you have to do whatever they did, what they said. What do you want to do? Now to later. So you want to do now on the left and later on the right? Like that? Okay, so this is now, and this is later. And then the other comparison then that's being made is days and months. And I'm going to put days on top and the months on bottom. And I'm abbreviating the days and months based on how we've already defined them. Right? Days of vacation, months of work. You could flip those and it'd be okay though, right? Yeah, absolutely. Okay, so how many days of vacation does he have now? 6. How many days of vacation will he have later? We don't know. That's the thing we don't know. So I'm going to put an X there. How many months has he worked now? 9. And if it helps, you can actually write the words days and months in here. You don't necessarily have to, but if it helps you can. So we don't know what it is now, but later it's going to be days here. And then how many months are we talking about in the future when we're looking to make the comparison to? Yeah, 2 years, so 24 months. So good job on changing that, recognizing we need to. Okay, fabulous. And then in solving this, what do you recommend? Cross multiply? Sure. Okay, so the first diagonal is 6 times 24. I'm going to leave off all the units because it's going to get really messy. And the second diagonal is 9x. So somebody with a calculator, tell us, what in the world is 6 times 24? $144. And what would our last step be? Divide by 9. So what's 144 divided by 9? It's 16. Is that right? Yep, 16. 16 what? Vacation days. Oh, I like that you put the word vacation in there. It's always a good idea when you're working with the problems to make sure that you actually answered the question they asked, because sometimes you've found good information, you're just not quite at the answer yet, right? So it asks us how many days would he earn? So 16 vacation days is the right idea. As you're taking a look, just like back in section 1, like section 1.1 in number theory, we talk about when we're doing problem solving, it's a good idea to make sure if the answer seems reasonable. Is it realistic? So if he had 6 vacation days for 9 months, does 16 sound reasonable? It sounds reasonable, right? So if he got 6 days in 9 months, what's he getting? You know, like he's getting a little bit less than a day per month. So 16 would be a little bit less than a day per month. Like there's a reasonableness to it that makes it seem like a good choice. Okay, if we had gotten to the answer 144 at the end for whatever reason, we should ask ourselves, what's going on? Because that's not reasonable. Okay, any questions on that one? Yes, ma'am. They cancel out. If I were to write them in, you would see. So, let me show you on this one. So this is 6 days, and this is this side. This is days, and then I have the 24 months, and I have the 9 months. So when I've multiplied these together, eventually I divide by the months, and so the months here are canceling out with the months here, and I'm left with the days for X. That's what's going to happen as long as you set them up. Like if we had used the 2 years, we would run into a problem, right? And it wouldn't work that way. But as long as we're setting it up comparison-wise like this, and you can either do it on like from the top to the bottom like we did, or across the top. So let me show you one other way we could set this up, just to kind of give you an idea, is that we could do now compared to later in fraction form like this. And we could say, well, now, and we can do our working compared to vacation across like this. So now I've spent 9 months working, and later I will have 24 months working. And you can see the months canceling out so very nicely on that form, right? And then over here on your vacation, now I have 6 days, and later I'll have X days. And so you can see the cancellation of your units a little bit better from that perspective, but you also see that we still end up with the same cross multiplication, right? 9x and 6 times 24. So this would be another version, just like we talked about the other versions down here on 621 and 622, the theorems. It would simply be another version of the same proportion, but set up from a different perspective. It's still equally right and still very good. There's nothing wrong with either one of those perspectives. Any other questions on that one? Okay, we're going to pause right there because that way I give you a little bit more than 20 minutes for your group work for the 2 sections, and we'll pick back up here on Friday.